Recall from a previous lesson that everything around you is matter, and that matter can have physical properties and chemical properties. Just like matter can have physical and chemical properties, it can also undergo physical and chemical changes. A lot of times in chemistry, we show a change by using an arrow. The stuff we started out with goes on the left side of the arrow, and the stuff we created is shown on the right side of the arrow. When you boil water, what do the bubbles contain? Hot air? Oxygen? Water vapor? Don't feel bad if you don't know the answer. This is a question that often gets answered incorrectly. To answer it, we would first need to determine what is happening to the particles in the water. When you add energy to the particles of a substance by heating it on a stovetop, it causes the temperature to increase, which means that the particles are moving faster. If they get moving fast enough, the temperature will eventually stop increasing and the bubbles will start forming. You have just reached the boiling point. If the temperature stops increasing, then where is all that extra energy going? It is being used to turn the liquid water into steam, or water in the gas phase. So what you're seeing inside of those bubbles is really just water vapor. This transition from a liquid to a gas is called a phase change. A phase change is the transition from one state of matter to another. You may already know the three common states of matter: solids, liquids, and gases. Solids have a definite shape and volume, meaning that for the most part they keep their shapes and they can't be compressed. If you were to add energy to a substance in the solid state, it would turn into a liquid. This is called melting, and the reverse process is called freezing. Liquids have a definite volume, but not a definite shape, which means that they will take the shape of their container, but like solids, they're not compressible. Hydraulics and car brakes work because liquids are incompressible, but they are still able to flow. Now, if we were to heat this liquid enough, it would turn into a gas. This is called vaporization, and the reverse process is called condensation. You may notice on a warm day, water droplets form on the outside of a cold drink. This is what happens when water vapor in the air cools down after coming in contact with your cold beverage. Gases do not have a definite shape or a definite volume. They will take the shape of their container and they can be compressed. So back to the bubbles in the boiling water. We now know that they are filled with water vapor, but why do they rise to the surface? Gases are a lot less dense than liquids, so they rise to the surface of a liquid. All of these transitions I just discussed are phase changes, meaning that the particles still have the same composition. Ice, water, and steam are all H2O, but they are in a different state. Phase changes are examples of a larger category of changes called physical changes. A physical change does not affect the composition of a substance. Other types of physical changes include changes in form. For example, when you crush a can, sharpen your pencil, or cut a piece of paper, you're not changing what it was you started out with, you're just changing its form. You still have the same atoms and molecules connected in mostly the same way. Even magnetizing a paperclip is an example of a physical change. So what if you take that piece of paper you just cut and you set it on fire? Do you still have paper? If you burn paper, what you are going to produce still has the same atoms as the original paper, but they are rearranged and will create entirely new substances with completely different properties. This type of change is called a chemical change. A chemical change is a change that involves a transformation into a new substance. Often we will call these chemical reactions. Examples of chemical changes include rusting iron, baking a cake, digesting your lunch, and tarnishing silver. One thing to remember about both types of changes is that when they occur, the amount of matter and the number of atoms you started out with will always stay the same. Physical and chemical changes will never cause a change in the amount of matter you end up with. For example, when you are boiling water, the water level may go down, but your water isn't disappearing, it's just being converted to another form, steam. Also, after you're done burning a campfire, it may look like all you have left with is ashes and something along the way disappeared. Really, what happened is you created a lot of carbon dioxide, which was released into the atmosphere. Matter was not actually destroyed in this process. So to summarize all of this information, matter is constantly changing around us. There are two major types of changes, physical and chemical changes. Physical changes can either be changes of state, changing among liquids, solids, and gases, or changes in form, like cutting, smashing, or bending. Either way, what you will end up with will have the same composition as what you started with. If matter undergoes a chemical change, the atoms will rearrange and form completely new substances with different chemical formulas and different properties, like when a plant uses sunlight, water, and carbon dioxide to produce carbohydrates and oxygen. In both a physical and chemical change, matter is conserved, meaning that during the process, particles are neither created nor destroyed.